In lesson 6.3, we're going to continue talking about the normal distribution. One thing that we can do to a normal distribution here is use our z-score formula here that we've already really talked about doing here, is taking the normal distribution and changing it to the standard normal distribution. So remember the differences here. The standard normal distribution is going to take the mean of the normal distribution and make it into 0. Of course, the standard deviation there falls also. Now, recall in lesson 6.2 here that we can use our stat tables to determine this given area right here. And we'll show you how we're going to come up with these two values in just a second here. But we could look up on the table here from 0 to z, we could use that table to find out the area. And this area under the curve here would represent the probability. Okay, so let me go back and read the problem here. I kind of got ahead of myself a little bit. It said, find the probability that a normal random variable with a mean of 10 and a standard deviation of 20 will lie between 10 and 40. Okay, so let's look how and review how we make this transformation. So obviously here, since 10 is the mean on the standard normal curve, then that's just going to be 0. So really using the formula is not necessary with the mean. But let's look at the 40 there. Okay, so what I'm going to do is find my z-score that corresponds to 40. So recall the z-score is x, which is our 40, minus our mean, which was 10, divided by the standard deviation, which is given to be 20 there. Okay, so I'll just do this kind of in my head here. 40 minus 10 is 30. And then 30 divided by 20, of course, is 1.5. Okay, so notice that we converted the 40 to the 1.5. So this is not really anything new. I think we did this in lesson 6.1. Now, so to find here the probability that we have something here that's going to lie in between 10 and 40, so this would be 10 and 40 on the normal distribution curve, but it would be 0 and 1.5 on the standard normal distribution curve. So what we could do, and I'm not going to do this in the video here, but we could look up, like we did in lesson 6.2, the area here, and the area would represent the probability. Okay, so in each of these problems, I'll actually never get to the final answer because I'm not going to take the time to look up on the t-table the area in between 0 and 1.5. That was lesson 6.2. It's fairly easy, and it kind of takes a lot of time to look that up on the table. So I'm going to sort of skip the absolute last step to get the answers. Now let's look at some applications of this. Okay, this one says the diameters of ball bearings are distributed normally. The mean diameter is 84 millimeters and the standard deviation is 4. All right, our question asked here says find the probability that the diameter of a selected bearing is greater than 81 millimeters. Now, I've got a standard normal curve here that I just kind of copy and paste and use over and over here. But what we have to do is convert our numbers to the standard normal curve. So, of course, that's using the z-score formula. So recall here, z is equal to x minus mu over sigma. Okay, and remember this is the mean and this is the standard deviation. So we're given here the mean is 84, standard deviation is 4, and what we're going to do is we're going to use our x value of 81. So 81, well 84 is the mean, so 81 is going to fall somewhere over here since it's less than the mean. So we're really just finding the z-score for 81 right now. So now let's plug this in. So let's see, x here was 81 minus our mean, which was 84. So notice this is going to be negative, so that makes sense. This is going to be on the left side, divided by our standard deviation of 4. So now this is going to be negative, that would be 3, negative 3 over 4, negative 3/4, which is about negative 0.75. Okay, so now let's look at this on our curve here. So there's negative 1, so negative 0.75 is going to be right in here somewhere. Okay, now since we've converted this sort of to our z-score, we can kind of answer or get to a point where we can answer the question. It says find the probability that the diameter of the selected bearing is greater than 81 millimeters. So I know this doesn't say 81 right here, but it represents the z-score of the 81. And so the ones that would be greater than, of course, would be to the right. So our probability here would be the area under this curve. Okay, so now I don't know what the area under this curve is. That's what lesson was 6.2 about. And so we could look up like a negative z to infinity table and look up negative 0.75, or we could do a negative infinity to negative z, and we could find this area over here and subtract it from 1. Either way we do it, we're going to go to the table to do that. Now again, I'm not going to do that for time's sake. So whatever our area is right here is going to be the probability that we have a ball bearing that has a diameter that's greater than 81 millimeters. Now let's look at another example. And pretty much all these examples are very, very similar. Okay, all the problems are pretty much the same. This one says the weights of newborn baby boys at a local hospital are believed to have a standard normal distribution with a mean weight of 4,032 grams. It's a good thing that's not like pounds. And a standard deviation of 663 grams. Now let's read our question. It says, if a newborn baby boy born at a local hospital is randomly selected, find the probability that the weight will be greater than 3,567 grams. Okay, so let's look at our z-score here for 3,567. So we'll get z is equal to, there's our x, 3,567. What, buddy?
It's sliding outside, okay?
Okay, go back in the under.
Just
Minus our mean.
Quietly.
No, go in under. And then recall divided by our standard deviation, which was 663. Okay, so now we're going to calculate that. Let me get my calculator here. Okay, finally got it now. I'm going to punch it in. We got 3567 minus 4032 is negative 465, and then divided by 663 is about negative 0.7014. I rounded off here that last decimal place. So now, on our standard normal curve here, let's notice again 0.7, or negative 0.7, excuse me, is about right there. Okay, so now to answer our question, again, it was find the probability that the weight will be greater than 3,567. Here's our z-score for that. So really much like the last problem here. All the weights that are greater than will be the area here under the curve on the right side of negative 0.7014. So there again, we look up on the table to find out what that area was. I don't know what it is. And that would give us our probability. Okay, let's go to another one here. Probably could have skipped that problem since it was so similar. Okay, now we're definitely going to watch this one now. This one has a little trick in it, and let's see if you can kind of spot it. This one says the weights of steers in a herd are distributed normally. Now, a steer is a cow, and that might be like a question you need to ask your parents, what makes a cow a steer. But anyway, the variance is 40,000, and the mean steer weight is 900 pounds. Okay, so did you pick up anything here that was different? I'll let you think about that just a second. It was this. Instead of the standard deviation, they gave us the variance. So recall the variance here is sigma squared. So if the variance is 40,000, then the standard deviation here is just going to be 200, which is the square root of 400,000. So a little bit tricky there. Now, from here on, it's pretty much the same as the last problem. It says find the probability that the weight of a randomly selected steer is greater than 520 pounds. So let's find our z-score here for 520 pounds. Z is equal to our x here, which is 520, minus the mean, which is 900, divided by our standard deviation of 200. Okay, so let me throw this in the calculator real quick. 520 minus 900 is negative. It's negative 380 divided by 200 is exactly negative 1.9. Okay, so let's mark 1.9 on my curve here. Okay, now we're looking for the probability that the weight is greater than 520 pounds. Of course, greater than would be on this side. It's real similar to that last problem now. So we're looking for the area that's under this curve. So there again, I'm going to look up in my tables for my standard normal table here, probably a negative z to infinity table of a z-score of negative 1.9 to find out what this area is, and that area represents that probability. Okay, now let's go ahead and look at this one. This one says the time spent waiting in line is approximately normally distributed. Look, lay on top. Lay on top. The mean waiting time is 5 minutes, and the variance of the waiting time is 4. So notice it says variance again instead of standard deviation. So if variance is 4, then our standard deviation is going to be 2. So now let's look. It says find the probability that a person will wait for less than, notice this is a little bit different than the last one, 8 minutes. So 8 is our x. Now let's find the z-score for that. So we'll have 8 minus our mean, which was 5, divided by our standard deviation of 2. So we'll get 3 over 2, okay, which in a decimal form here is about 1.5. So over here about 1.5 is where that would lie on our standard normal table. So that, again, that represents the 8 minutes. Now we're looking for the probability that a person will wait for less than 8 minutes. So less than would be this time the area to the left of our 1.5 z-score here. Okay, so there again I could do like a negative infinity to Z-table probably and look up this area. So whatever this area is our probability. Let's look at one more. Now, instead of, go ahead and kind of skip to the question here. Instead of like greater than or less than a certain value, now this is one where it says you have to go between two values. Okay, so it's a little different, and that's why I'm kind of doing this one, and then we're going to stop here. So the soft drink machine outputs a mean of 26 ounces per cup. The machine's output is normally distributed with a standard deviation of 2 ounces. And so now the question again was the probability of filling a cup between 28 and 30 ounces. So what we have to do this time is we have to find the z-score for both 28 and 30. Okay, so let's find our z-score first for the 28 here. We'll say 28 minus the mean, which was 26, divided by the standard deviation of 2. So that's going to be 2 over 2, which is 1. Now I'm actually going to do this. I'm going to call this z sub 1. Okay, and so now for z sub 2, we're going to let that x value be 30. So I have 30 minus the mean of 26 divided by standard deviation of 2. So that'll be 4 over 2. So z sub 2 here, 4 over 2 would be 2. Okay, so we're looking in between here z-scores of 1 and 2. So the probability here that we fill in between, which on the standard curve would be 28 and 30, but on the standard normal curve it would be 1 and 2. Okay, so all we have to do again is find this area. So whatever this area is, I don't know what it is our answer. Okay, so remember when you find the area in between, you can look at the area to the left of 2, which would be negative z to 2, and then subtract the area from negative infinity, I said that wrong, to positive 1 and subtract that. Again, that was from lesson 6.2, so this part's not that difficult. Okay, I do have a few more examples, but I think I'm going to stop the video here. I believe they're the same. I'm just going to look at them real quick just to make sure. Yeah, that's pretty much the same thing. Now again, be careful. Like that one says variance, so standard deviation would be 5. I believe this one is the same too. Yeah. Yeah, these are still pretty much the same here. Okay, that's it.